Alright guys, we're here on the last section of chapter 6, recursively defined sequences. How can you define a sequence recursively? And we are on page 183. So, recursive. Actually, let's look at the examples real quick. So you have 1, 1, 2, 3, 5. This is what I'm looking at here, 1, 1, 2, 3, 5. And the example that they give to you later, do they tell you what it looks like? Yes. So to get, we said 1, 1, 2, 3, 5. And the pattern here is that you are taking the previous two numbers and adding them to get the next number. So to get this one, you have to take these two numbers, add them, and then to get 5, you have to add 2 and 3. All right, so what this is saying is to get a number in the n spot, so n is any given spot, you take the number before, so one spot before, and you take one number 2 spots before, and you add them together to get that one. So what this would look like is, again, we would add these two to get 3. And I'll just change the colors so make it a little more visually clear. Add these two, that's 5. Of course I said clear and then I pick a color that you can't really see. Let's pick red. So you add these two, and then you add these two. Right? So if you're thinking about the 7th spot, what are the two previous spots? 7 minus 1 is the 6th spot, and 7 minus 2 is the 5th spot. So I have the 5th and the 6th spot added together to get the 7th spot. To get the 8th spot, I have to add the last two, which are the 6th and the 7th spots. So that will be 21. Okay, so that's what we're going to be doing. We're looking at the relationship at previous numbers and what you do to them. So in this case, it's just adding the one before, the one immediately before, and the one two before, two previous. So recursive rule is pretty much what? How would I define that in my own words? A rule that is defined using, or a rule that is defined by referring to itself or previous. Referring to itself. If I had to break it down some more, I would say a rule that refers to previous terms specifically. An explicit rule does not do that. It doesn't care what happened before. It just will tell you what happened. Oh, you're trying to find the 10th number? Okay, here's the formula. For the recursive rule, you say, oh, you're trying to find the 10th number? You have to refer to the 9th number or the 8th number or whatever. That's what I mean by previous terms specifically. Okay, moving on. A recursive equation for arithmetic sequence where D is the common. So let's say I'm adding 5 each time. So let's say I start off at 7, and then I go 12, and I go 17. So this is saying, okay, you have the number you had before, and you add 5. So what that would look like is a to the n minus 1 plus 5. Notice I start off at 7. Do we see 7 anywhere here? No, right? It doesn't tell us. So what you have to do is you have to define it yourself as well by saying the very first number we start off is 7. So all this is necessary. Recursive, and I'm actually going to change to blue because it's just more appealing to me. Recursive equation for a geometric. Now let's say we're taking 7 and we're multiplying by 5. So you have 35. Oh boy, what's 35 times 5? 150 plus, 175. 35 times 5. 35 times 5 is 175 times 5 is 875. So here the common ratio is 5. So a of n is you take the last number. A of n minus 1 means the number right before n, which is the very last number, times 5. or 5a to the n minus, or of the n minus 1. So notice here that we also, even though we start off at 7, we don't see 7 anywhere in the formula, so it's or in the equation. So it's important for you to define. This is called the base case, the starting point. All right, so if we move on, let's see here. Let's get into some examples. I would say the easiest way to do everything throughout anything that has to do with recursive sequences is to write out the first at least 3. This one says 6, and that's what you got to do anyways. But to define it, it definitely helps if you write out the least 3 at least. So it's telling you start off at -2. So I'm actually going to make a little table. So where n is 1, a of n, so essentially this is just your x and y. X and y. So a of 1 is -2, and it says to take the last number and multiply it by -2. Take the last number and multiply it by -2. So the one previous, a of 2 is 4, I gotta multiply by -2. So 16, 5, -32, and, sorry, 6, +64. So that's what you do. You make a little table for each of these. This is your starting point. So you'll have 1, 2, 3, 4, 5, 6 on all these. And then this is what it tells you to do. It tells you to add 3. So each time you just add 3. -1 plus, or -4 plus 3, -1 plus 3, 2 plus 3, and so on and so forth. This one tells you to multiply by 1.5, so you'll be multiplying like you did here. This number right here is your starting point, and then you graph by saying this is x and this is y. So that's it for that section. Moving forward, these are all exactly the same. Write a recursive rule for the sequence. So you have your starting number. So let's just start off with that. And then what's happening here? We are, let's see, 12 divided by 36. We are dividing by, or you could say we're multiplying by 1/3. Yeah, let's just say that. 12 divided by 36, 1/3. 0.33 is 1/3. Okay, so you take, to find any given position, you take the previous number. Sorry, we already said it, so I'm actually going to write it just nice and neat. 1/3 times the previous number. That's it. Here, we are adding, how much are we adding? We're adding 5. So we're going to say a of 1 is equal to 9. A of n is the last one plus 5. That's it. You take the last one, you add 5. Okay, erase everything. 7. Honestly, 7 and 8 should serve as perfectly fine examples for 9 through 13. This is your A1. You have to figure out what's happening each time. In this case, it looks like we're dividing by 5. Dividing by 5 is the same thing as multiplying by 1/5. I will give you verbal descriptions so you can write the equations on your own. Multiply by -3. Divide by 5. Multiply by 1/5. Same thing. How much are we adding? 6 add 6. So 9 and 10 are going to look very similar. 11 is going to look like number 8 because you're just adding 5. Or 6 rather. And again, this is your first term. 7, 8, 31, 25. Okay. These ones are also, let's see, you basically treat this 15, you treat your sequence like this: 15, 12, 9, 6, 3. You're just subtracting 3. Your formula will look similar to number 11 and number 8. This is dividing by 5 or multiplying by 1/5, so it's going to look very similar to this. But your first term is 20, and your first term here is 15. Write an explicit rule for the recursive rule. So write a recursive rule for the explicit rule. So this is what the explicit rules look like. So I'm going to write things that look like this. And the easiest way to do this, or not the easiest way, no, it's definitely the easiest way, or at least it is to me, sorry. The easiest way for me to do this is to write out a few numbers in a sequence first. So we start off at 4, and you multiply by 3. So 12, 36, multiply by 3, 108. So if you're multiplying by the same number, is that an exponential function or a linear function? If it's multiplying by the same number. Turns out that it's exponential. So you'd say a of n equals 4 times 3 to the n. You start off at 4 and you it's actually 3 minus 1. Why is that? Because if this is the first number, the second number, the third number, and the fourth number, we could say 1 minus 1 is 0, 3 to the 0 power is 1, 4 times 1 is 4. 2 minus 1, 3 to the first power is 3, 4 times 3 is 12. So that one checks out. Let's see here. We have a sequence starting at 6, and you add 11 each time. So 6 plus 11 is 17. 17 plus 11 is 28. So let's see, what can we do? We could say if the number is changing by 11 each time, then that's what we have to add each time. So we have a of n equals 11 x, or sorry, 11, oops. Oh, dang it. Sorry, 6, 17, 28. A of n equals 11n. Let's see. Minus, what do I do to get 11n minus 5? So 11 times 1 minus 5, 11 times 2 minus 5, 11 times 3 minus 5, 33 minus 5, 22 minus 5, 11 minus 5. Here we're multiplying by 5, so negative 1, negative 5, negative 25. And again, since we're multiplying, it's just a, what is it? It's a exponential function. Y equals negative 1 times, sorry, I should be saying this in a of n equals negative 1 times 5 to the n minus 1. That's it. Write a recursive rule for the explicit rule. Again, I'm going to sequence these out first before I do any explicit rules. So let's plug in 1. 6 times 1 is 6. 6 plus 2 is 8. Now we're going to do 2. 6 times 2 is 12. 12 plus 2 is 14. And lastly, we're going to do 3. 6 times 3 is 18. Plus 2 is 20. So our a of 1, the first term is 8. And to write a recursive rule, what do I have to do to the last number? What's happening each time? You're adding 6. So you take the last number and you add 6. Here, we're going to plug in 1, 2, and 3 just to get the first 3 terms. So 1 minus 1, 0. So I have 1. I have 2 minus 1, negative 3. And 3 minus 1 is 2. Negative 3 squared is 9. So I have a equals, the first term is 1. I have to take the last term, and each time I'm multiplying by -3. So I'll say -3 times a to multiply by the last number. -3 times the last number. Lastly, again, just going to plug in 1, 2, and 3. And -2 times 1 is -2. -2 plus 1 is -1. -2 times 2 is -4. -4 plus 1 is -3. What's happening each? Oh, we'll see. -2 times 3 is -6. Plus 1 is -5. So my first term is -1. What's happening each time? I'm subtracting by 2. So I will say, you start off with the previous term, and you subtract 2. Whew. Write a recursive rule, then write the next two terms. We've been practicing writing a recursive rule, so this should not be any different from the previous one. Then write the next two terms. Oh, sorry, sorry, I worked it out already. So you should notice that this is these two added together. This is these two added together. So how do we refer to that? We say a of n is equal to the previous one added with the one from 2 before. If you flip those, like if you wrote it like this, that's okay too. It doesn't really matter. Here, let's see, how do I get -2? I have to say 1 minus 3. So this one, actually, the order does matter because, 1 minus 3 is not the same thing as 3 minus 1, right? 1 gives us -2, and 1 gives us 2. So what I have to do is take the 1 from the very first one. So the one to get the third spot, I take the first spot and minus the second spot. So a of 3 is equal to a of 2, or the second term minus the third term is equal to the second term. Oh, no, I wrote that wrong. It's the first term subtracting the second term. So a of n, careful now, is the starting from 3, how do I get 1? I have to subtract 2, right? So n minus 2 minus the one right before it, so that one, n minus 1. So let's see, this is 1, 2, 3, 4, 5, 6. So let's check 6. The sixth term, I have to take the fourth term and subtract the fifth term, and I get 12, which is correct. Okay. Then write the next two terms. So we have 16 plus 26 is 30, 42. 42 plus 26 is 68. -7 minus 12 is -19. And 12 minus -19 is positive 31. Go ahead and try this one on your own. If you have any questions, this one does involve multiplication, so this will be different. But you guys should really focus on finding, how to refer in a recursive rule, how to refer to the previous terms. So that's it for this section. You're done with chapter 6. Good luck on your chapter tests. If you don't understand anything, ask your teacher or let me know.